Hey, welcome everybody. In this video, we're going to take a look at the 7.4 notes for Algebra 2, where we're going to focus on adding rational functions. So we're going to start out by just kind of reviewing how do we add fractions, because ultimately that's what a rational function is. So if we look here, it says to work in groups. You could pause the video, try it on your own first, but I'm going to go ahead and take a look at the first one. The one thing you have to pay attention to is when you are adding any kind of fractions, you must have a common denominator. Without it, you cannot add the fractions together. So in this example, we have a denominator of 3 and 6. Their common denominator would be 6. Some people might think 3 because they're thinking common factors, but a common denominator is actually the least common multiple. So when you're looking at two numbers, it's at least the biggest number. In this case, the biggest number is 6. 3 does go into 6 evenly, meaning it's a factor or a multiple. So 6 is the common denominator. So if we're going to add these together, the first thing we need to make sure is that we have that 6 on the bottom of each of our fractions. The first fraction is 2/3. So we have a 3 on the bottom, not a 6. The way we're going to make the 3 a 6 is we're going to multiply by 2. And if we multiply the bottom by 2, we're going to multiply the top by 2. So 2/3 is going to be rewritten as 4/6. One thing to pay attention to is why, if we multiply the bottom, do we have to multiply the top? And that's because if you take and look at just the 2/2, that's 1. And when you multiply something by 1, we are not changing the value. So over here, we already have the denominator of 6, so we just go ahead and rewrite it. Now, when you add, you only add the numerators. So we're going to add 4 plus 1 to get 5, and that denominator stays the same. So our answer becomes 5/6. All right, pause the video, try the second one. All right, this time we have denominators. Well, first off, it is addition, just like before. So I make a note that I need a common denominator because without it, I'm not going to be able to do it. All right, this time we have 5 and 6. Our biggest number is 6, but 5 will not go evenly into 6, or 6 is not a multiple of 5. So their least common multiple this time is going to be the product of 5 times 6, which is 30. So if we're going to add these, we're going to need to get 30 on the bottom of each of these fractions. So the 3/5, we're going to have to multiply the 5 by 6, which means we're going to multiply the 3 by 6. For the 6, we're going to multiply it by 5, which means we multiply the top by 5. 6 times 3 is 18. 5 times 5 is 25. Now that we have a common denominator, we can go ahead and add the numerators. So 18 plus 25 becomes 43. Now, some of you guys might be thinking, okay, well, we can write 43 as a mixed number, but that's not something we typically are going to do. It's much easier to work with improper fractions than it is to work with mixed numbers. So leave it like this, with the exception of if it does reduce, we want to simplify. All right, so what we're going to do now is take that idea of adding fractions and apply it to rational functions. So what we need to add two fractions is the least common denominator. Now, technically, any common denominator is going to work, but we want the least common denominator to make it as simple as possible. Another way to think of the least common denominator is it's always going to be the lowest common multiple of all of our denominators. So we've got a couple examples here that are just going to practice figuring out what those least common multiples are. So there's different ways to do this, but the way I always think about it is if I'm looking at two terms, I'm going to figure out what its factors are. So the factors of 2x are 2 and x. The factors of 3x squared are 3 times x times x. Now, when I'm trying to figure out what that least common multiple is, the LCM, least common multiple, I'm going to take every factor from the first, so 2 times x, and I'm going to add any new factors from the second. So this time 3 is new, so we're going to multiply by 3. there's two different x's here. We have one, we need to have a second. So our least common multiple is going to become 6x squared. All right, and that's something that's going to help us later on. Now, if our expressions end up being binomials or terms that are factorable, I'm going to factor. So in this case, we have x minus 3, which we really can't do anything with. And then x squared minus 9, that's a difference of squares, so it's going to factor into x plus 3 and x minus 3. So our least common multiple between those two functions is going to be everything from the first, so x minus 3. And then you're only going to add the factors that are new. So in this case, we're going to add x plus 3, and that would become our least common multiple. Understanding how to find the least common multiple is how you find the least common denominator. So if you take a look at the next set of problems, it's really just going to extend on that idea. So here, all right, we have that denominator of 2x and 3x squared. So if we're looking for the least common denominator, it's the same thing as the least common multiple. Well, we focus on the factors of only the denominators. We did this above, so it's simply going to be that 6x squared. Because the least common multiple of 2 and 3 is 6, and the least common multiple of x and x squared is x squared. And then over here, same kind of idea, right? We're going to try to factor our denominators. We can't factor this. This is going to factor into x plus 3 and x minus 3. So that least common denominator is everything from the first, x minus 3, and then anything new, which is that x plus 3. So definitely going to be a key concept to understand is how to find that least common multiple, which will become our common denominator. All right, so the steps that we're going to follow in adding or subtracting rational expressions. Now today we're just going to focus on adding. Next class we'll introduce subtraction, but it's very similar. So what we're going to do is step one is always going to be to factor the denominators if possible. So we only factor denominators. Don't worry about the top. Then we're going to get a common denominator, which when we do the common denominator, we always want it to be the least common denominator. From there, we add or subtract the numerators, and then we're going to reduce if possible. So you're not always going to be able to reduce, but we're going to reduce if possible. All right, so let's see what this looks like with these rational expressions. So my approach is always this. I look and I see its addition, so that tells me I need a common denominator. So I look at my fractions, x plus 2 cannot factor, x plus 2 cannot factor, and they're the same. So our common denominator is simply x plus 2, which means we're ready to add. So we can add the 3 plus 4 to get 7, and then x plus 2 stays on the bottom. So we definitely don't want to overthink this, but in terms of adding, once we have a common denominator, simply add the numerators. This is not going to reduce, so that's the answer. Now, those are the easy ones. They're not obviously always going to be that simple. So let's take a look at the next one. And I would recommend you guys pause the video and try it on your own. All right, for this one, again, it's addition. Right away I know common denominator. So I'm going to look at my denominators. In this case, x minus 2 is not going to factor. X squared minus 4 is a difference of squares, so it's going to factor into x plus 2 and x minus 2. So our common denominator is x minus 2, so every factor from the first, and then anything new, which becomes x plus 2. So if we are going to be able to add these two fractions together, this common denominator is, whoops, I did not mean to cross that out. Sorry. The common denominator is going to need to be on the bottom of each fractions. So what we're missing here is the x plus 2. So we're going to multiply the top and bottom by x plus 2. So what I like to do is I know that when I multiply x plus 2 and x minus 2, it's going to give me that common denominator. So what I normally do is I write this as CD. It tells me that I'm going to have the common denominator on the bottom. To get it on the bottom here, I had to multiply the x and the x plus 2 together. Over here, you have the common denominator, so you don't have to multiply by anything. Once you have that common denominator, you can go ahead and add the numerators together. So x times x is x squared, x times 2 is positive 2x, and we're going to add 5. And then the common denominator goes on the bottom. X plus 2, x minus 2. Now, we always want to check and see if we can reduce, because that was the last step, reduce if possible. Okay, so we identified the common denominator, we got the common denominator, we added the numerators. Now, the only way I'm going to be able to reduce is if the numerator has one of these denominators as its factors. And with there being a 5 here, it's not going to work, so that tells us that we're done. So we don't want to make it harder than it needs to be. All right, let's go ahead and take a look at the next example. All right, so same idea. The approach is we see addition. Automatically, that tells us we can't do anything without a common denominator. So when we look at this denominator and try to factor it, we have 2 as a GCF and x plus 3. This is a difference of squares, which is going to factor into x plus 3 and x minus 3. So making sure you know how to accurately find a common denominator. You're going to take everything from the first. So 2 and x plus 3 will be part of our common denominator. And then when you look at these factors, you only add anything new. So the x plus 3 is not new, but the x minus 3 is. So this is what we need to have on the bottom of each fraction. So the way I, like I said, always think about it is, I'm going to have a common denominator on the bottom. To get that, this first fraction on the left, we are missing the x minus 3. So we're going to multiply the bottom and the top by x minus 3. So I'm going to put x times x minus 3. This denominator is missing the 2. So we're going to multiply the top and the bottom by 2. So I'm just going to put 4 there. All right, at that point, we can now simplify. So we're going to get x squared minus 3x plus 4 over our common denominator, which is 2, x plus 3, and x minus 3. Now again, you would only reduce if possible. Well, having a 4 here, the possible factors of 4 would be 1 and 4 or 2 and 2. So there's no way you're going to get either one of those, which means we're done. Okay. All right, so that's kind of the idea of how we're going to add rational functions. Now, the only thing that we didn't do, because the directions did not specify, but most of the time when you are working with these rational functions, you want to make sure to identify the domain restrictions. So I'm going to just include that because it is something you're ultimately going to have to know how to do. So if we have 7 over x plus 2, we know that the denominator cannot be 0, so x cannot equal negative 2. And again, this is just what's called the domain restriction, which most of the time we will include with these rational functions. Over here, if my denominator has factors of x plus 2 and x minus 2, then x cannot be plus or minus 2. And then finally over here, if our denominator has factors of 2, x plus 3, and x minus 3, nothing's going to make the 2 0, but x cannot be plus or minus 3. So that's just something to make sure you understand how to do. All right, guys, hope you found this video helpful. Talk to you next time.